we will take up map entered variable technique now. With the map entered variable technique, we will be up by one module. The second module will be complete once we are done with the map entered variable technique. Just to before getting into what map entered variable technique is, so you try to recall the drawback of your K-map. So, if you can try to recall the drawback of your K-map, I said it is not, we cannot comfortably apply K-map to 4 or 5, more than 4 variable expressions. So, in such cases, we can expand the degree of your K-map by applying map entered variable technique by making an entry, making the entry of into the K-map in terms of the variable itself. So, say you have a 5 variable expression and you need to solve it using K-map. The 5th variable, say A, B, C, D, E are the 5 variables. The 5th variable E is directly entered into the K-map, thereby extending the usage of K-map by 1 degree. So, we will take up an example directly and see how map entered variable technique can be applied for expanding the use of K-map for simplifying the given Boolean expression. So, we will take up a 6 variable K-map and try to simplify it using a 4 variable K-map. So, we have a 6 variable expression and you can write K-map for a 4 variable expression, and please note you can see this expression as min terms, don't care, and along with min terms you have something called as EMF5, EM7, FM9 and so on. What this designate is the min terms M0, M2, M3 are there, and M5 is I only when E is 1. So, M5 indicates that min term M5 is I only when E is 1. When E is 0, this is going to be a 0, and M7 min term M7 is going to be I only when E is I. F again is I when 9 is I when F is 1. And it is 0 otherwise, and along with this you have don't cares 1, 13 and 13 and 14. So, what we do here is in the map entered variable technique, the variables are fitted into the K-map directly. So, we will take the case because it is a 4 variable expression, I can write a K-map comprising of 16 cells with respect to variables A, B, C, D, and E and F I try to fit directly onto the K-map. First case we will consider E is 0 and F is 0 and write the K-map for A, B, C, D, and in the second case we consider E is 1 and F is 0 and try to fit variable E into the K-map, and finally we will consider E as 0 and F as 1, and we will write one more, we will generate one more K-map, and finally write the expression, simplified expression. So, we go something like this. So, because it is to be expanded, 6 variable expression needs to be fit into a 4 variable K-map, we write a K-map comprising of 4 cells. So, 16 cells with AB on one side and CD on the other side. So first we will map this onto the K map. So M naught, this is 0, 1, 2 and 3, this is 4, 5, 6 and 7, and this is 8, 9, 10 and 11, this is 12, 13, 14 and 15. So M naught is a I, M2 is a I, M3 is a I, and M11 is a high, M15 is a I, and don't cares are 1 is a don't care, 13 is a don't care, and 14 is a don't care. And coming to 5, it is E, indicating M5 is I when E is I. So it is dependent on E. So if E is I, it is going to be 1. If E is 0, it is going to be a 0. Likewise, 7 is also E. And when it comes to 9 I mark it as F, and the rest of them are 0. Now we will consider the case of E is equal to 0, F is equal to 0. Later we will take E as 1 and F as 0, and finally we will draw one more K map for E is 0 and F is 1. So, and arrive at different possible solutions. So, now for the case of E is equal to 0 and F is equal to 0, this map gets reduced to something like this. We have AB and CD. So, this is 0 0 0 1 1 1 and 0 0 0 1 1 1 and 1 0. And now this I am considering for the case E is equal to 0 and F is equal to 0. Since E and F are 0, since E is equal to 0, this is 0, and since F is equal to 0, this becomes 0, and the rest of them, they remain the same. So, since E is equal to 0, all the cells corresponding to E is made 0. Since F is also 0, cell corresponding to F is made 0. Now, we will try to look for adjacent ones. So, you can see these 4 form adjacent for group of 4 adjacent ones. This becomes a quad, and if you can look into this, these 2 form a pair. So, we do not have a provision for forming a quad. So, we end up getting one quad and one pair. So, what is common here? We have A, B is common, and here what is common? We have A, C, T. So, this is the case when F is equal to 0 and E is equal to 0, and this, let me call it as MS naught, wherein E and F are 0. So, this is going to be AB plus ACD. Now, I will consider the next case wherein E is equal to 1 and F is equal to 0. So, we will rewrite the K map. So, we have AB on one side, CD on the other side, 0 0 0 1 1 1 and 1 0, again 0 0 0 1 1 1 and 1 0. Now, it is E is 1 and F is 0. So, since E is 1, the cell corresponding to E, I make it as 1, and F is 0, cell corresponding to F, I make it as 0, remaining, they remain the same. Because 1 is already accounted for, so we will make all the cells 1 here. So, we will only consider E as 1. So, cell corresponding to E as 1, remaining we will make it as a don't care. So, because this one has been already accounted here, so we will consider only the cells wherein E is I. So, we end up getting this. So, you can see we have 4 adjacent ones. So, you can either group these two ones along with this or along with this to form a quad. So we end up getting what is common here, A bar and D. So we end up getting A bar D. So this we will call it as MS1. So MS1 is going to be A bar D. So this is for E is equal to 1 and F is equal to 0. And finally we will have to consider E is equal to 0 and F is equal to 1. So what I do, I will make corrections here only. So F is 1, cell corresponding to F is 1, remaining we will E is going to be 0, and these ones I will make it as a don't care, because this is already been accounted for. So the only the cell corresponding to F I make it as 1 and remaining I will make it as don't care, 0 I will leave it as it is. And if you can see, these 4 can be grouped forming a quad, and what is common here? Here A is common and D is common. So this happens to be MS2, MS2 is AD. Finally, we will arrive at the expression, we will write the final expression. So it is going to be MS naught E is 0, F is equal to 0. So we have MS naught plus E into MS1. Why E into MS1? Because E is 1, and finally F into MS2. So your final simplified expression is going to be AB plus ACD plus E into MS1. So it becomes A bar DE and plus F into MS2, that is AD. So this is your final simplified expression, and see we have fixed the drawback of your limitation of your K-map, wherein it could not be easily applied for 4 variable expression just by entering the fifth or the extra variables directly, mapping the extra variable directly into the K-map. But only thing is, you will have to rewrite the K-map for these many number of times. Initially for considering only the 4 variables, next considering the 5th variable, and finally considering the 6th variable. If at all it is for one more variable, you will have to extend it by one more K-map and finally write the expression. So this is how we use map entered variable technique to simplify a given Boolean expression. We will take one more example and try to illustrate how MEV can be used. Okay, we will take 2 more examples here. So we have a 4 variable expression and asked to solve using a 3 variable K-map. So we, as I said, we can expand the degree of your K-map by directly entering one of the variables into the K-map. So because it is a 4 variable expression, now A, B, C, D are the 4 variables, but I use only a 3 variable K-map. So with 2 power 3, that is 8 cells, and directly make an entry of D into the K-map. So if you can see, I am writing a 3 variable K-map, A on one side and BC on the other side, 0 and 1. We have different combinations of BC, and you can see D is D is I for only these 2 cases. So when D is 1, ABC bar min term and ABC is I, we have these are the 2 cases wherein it is dependent on D. So we will directly map onto the K map. So A bar B bar C, this is the first term, and next we have is A bar B C, this is the second term, and coming to this, this is dependent on D, A bar B C bar, this term, and this depends on D. If D is I, this is going to be I, and this term is A B C D. So this corresponds to A B C, and whether depending on whether D is I or not, this min term is going to be a 1 or a 0. If it is D is I, this is going to be 1, else it is going to be a 0. So we have enter D into these two cells. And please note, and this is A, B bar, C, I have indicated, I put it inside the bracket indicating it is a don't care term. Not necessary always it is to be designated as D. If anything is put inside, if any literal is put inside a bracket, it indicates a don't care term, and A, B bar, C is a don't care term, and this corresponds to A, B bar, C, A, B bar, C. So, we have made the entries into the K map. Now, we will have to consider it for D is equal to 0 and D is equal to 1. D happens to be the extra variable. So, we will consider the case of D is equal to 0 and D is equal to 1. Now, here we consider it for D is equal to 0. So, what happens here is we have two adjacent ones. This can be grouped as a pair, and what is common here is A bar and C is common. So, here MS naught is going to be A bar C. And coming to D is equal to 1, when D is equal to 1, these cells become 1, and because this 1 has already been accounted in MS naught, we will put it as a don't care. And if you can look into this, we end up getting a quad here, group of 4 adjacent ones, this is a quad, and this is a pair. We end up getting one pair and a one and quad. So, what is common here is we have C is common, two variables are eliminated, and what is common here is AB is common. So, here MS1 is going to be AB plus C. So, final expression is going to be MS naught plus D into MS1. So, it is A bar C plus ABD plus CD. So, this is how you arrive at a solution for this particular simplification of this particular expression using a 3 variable K map. Had you used 4 variable K map, it would have been simple. You could expect a question something like this, wherein you will be asked, you will be given a 4 variable expression, apply MEV technique and solve it using a 3 variable expression. In such cases, you will have to go with this method for simplifying given Boolean expression. So, what we do is we will try to fit the extra variable directly into the K map, consider the expression for fourth extra variable equal to 0, arrive at the solution, call it as MS naught, and considering D the extra variable as 1, call it as MS1, arrive at the expression, finally combine those two as MS naught plus 4th variable into MS1. If you have 5th variable, it is going to be 5th variable into MS2 and so on, like we did in the previous problem. So, we will take up one more example here. If you can see, this is again a 4 variable expression A, B, C, D, E. Here we have min term 0, 4, 5, 7, 9, and don't cares are 6 and 11, and coming to this, this is E. These terms M1 and 15 are I when E is equal to 1. So, we have mapped it directly onto the K map. So, here this is M naught, 4, 5, 7 and 9, and don't cares are these are the don't cares, that is 6 and 11 are the don't cares, and E is 1 and 15. So, what we try to do here is we will take the case for E is equal to 0, and when E is equal to 0, we will leave this as 0 and try to simplify the given try to simplify this, try to identify groups and try to eliminate the variables. So, if you can see here, these 4 ones, they form a quad, and coming to these 2 ones, they form adjacent ones, a pair, and this to form a pair. So, we end up getting a quad and 2 pair. So, what is common here is we have A bar is common and B is common, and coming to this pair, we have A bar, C bar, D bar, A bar, C bar D bar, B plus B bar they end up being 1 and is eliminated, and coming to this pair we have A B bar D. So, here MS naught is going to be A bar B plus A bar C bar D bar plus A B bar D. This is your MS naught. Now, we will consider the case wherein A is equal to 1, and we will mark all the ones as don't cares because it has already been accounted in MS naught, and we will make those cells wherein E as the influence as 1, E is 1 and here E is 1. So, accordingly we end up getting a quad. This is going to be a quad, and you can pair this along with this or this to form a pair. You can pair this along with this or this. Now, I will just try to pair it with this. So, if you look into this, what is common? We have A bar is common and we will have A bar and C bar common, and coming to this pair we have B C D common. So, here MS1 is going to be A bar C bar plus B C D. So, your final expression is going to be MS naught plus the additional variable E into MS1. So, MS naught is A bar B plus A bar C bar D bar plus A B bar D plus E into plus A bar C bar E plus B C D. So, this is your simplified expression. So, this way we can extend the K map by directly making the entry of the additional variables into the K map. So, we will take up one final example to see how MEV technique can be used. So, herein we have 7 variable expression, and we are using 7 variable, we are using a 4 variable K map to solve a 7 variable expression. So, you can see A, B, C, D, E, F, G are the 7 variables, and we have min terms 0, 3, 13, 15, don't cares 1, 2, 7, 9 and 14, and the terms M6 and M8 are E dependent. So, if E is 1, M6 is I, and if M6 and M8 are I, and if it is 0, if E is equal to 0, these min terms are going to be absent. It is dependent on E, and M12 is dependent on F, and M5 is dependent on G. Accordingly, we write a 4 variable K map and make entries into the K map. We will try to map this expression onto this K map. You can see min terms 0, 0, 3, 13 and 15, and don't cares are 1, 2, 7, 9 and 14, and E is M6 and M8 are E, M12 is F, and M5 is G. So, we have mapped the given expression onto the K map. So, we start with initially find MS naught wherein E, F, G are 0. So, considering E, F, G are 0, so we will try to only group the min terms and the don't cares, and we end up getting this. So, what we try to do here is we will try to group, we will try to identify the adjacent ones. So, here these form a quad, and if you can look here, this we do not have any adjacent force, these two form a pair. And if you take this particular quad, so what is common? A bar B bar is common, we end up getting this term. And if you look into this pair, we are getting A, B and D is common, we end up getting this term. So, for the case E is equal to F is equal to G is equal to 0, that is MS naught, this is the reduced expression. Now, we will consider E is equal to 1 keeping F and G as 0. So, we get E is 1 wherever we will make the cell corresponding to E as 1, and remaining we will keep them either as don't cares or zeros depending on your expression, and we end up getting this. So, if you can see this 4 together form a quad and these two form a pair. And if you look into this, what is common here? A bar is common and C is common. So, in this quad we have A bar C common, we end up getting this. And in this pair what is common? We have A, B bar and here you can pair this along with this, or you can consider these two as adjacent one and pair. So, if you are considering these two, you end up getting B bar C bar D, and if you end up pairing this, it is going to be A B bar C. So, it is going to be A B bar C. So, either solution is right, need not worry. So, you can either pair group these two as pair or these two as adjacent ones and pair them. So, accordingly you get this expression. And coming to E is equal to G is equal to 0 and F is equal to 1, make the cell M12 as 1, remaining you just leave it as you just consider F12 as 1, remaining you either map it as don't care or zeros depending on the expression. And here you can see this forms a quad and you end up getting AB. So, this is corresponding to MS2, and finally, we will consider E is equal to 0, F is equal to 0 and G is 1. So, cell M5 is made 1 and remaining is reflected as per the expression. And if you can see here, you can either group this as a quad or this as a quad. Or this as a quad. There are different ways you can group them. So, if I consider grouping these as a quad, we end up getting B is common and D is common. You can do either, you can combine this as a quad or this as a quad, but it ends up eliminating two variables. It is either BD or it is either B bar D and so on. So, this should be the expression. Finally, we will combine everything. So, Z is going to be MS naught plus E into MS1 plus F into MS2 plus G into MS3. So, it is going to be A bar B bar plus ABD plus F into MS2, that is A bar CF plus A bar, here it is E into MS1. So, it is going to be A bar CE plus A B bar C E plus AB into F into MS2, that is ABF, and finally we have BD. So, you may get a different solution, but the number of terms is going to be constant. Depending on what you are considering, what group you are considering, you may not end up with a single solution. We may get a different solution as well, but all please make sure the number of terms is going to be only this much. So, this is how we extend a K-map for more number of variables using MEV technique. So, here we could easily use K-map, 4 variable K-map to solve a 7 variable expression. Only thing is, number of K-maps you need to consider extends. So, because it is a 7 variable K-map, one for 4 variable, 5, 6 and 7. You need to consider 3 extra for 3 extra variables and accordingly combine all those all the results to arrive at the final solution. So, with this we are completing our module 2. So, more examples will demonstrate when during our offline classes. So, as of now we have demonstrated the K-map, Queenie-McCluskey method, Patrick's method, MEV method with very few examples. We will take up more examples in the offline classes. So, with this we are completing module 2. We will start module 3 in the next session.